Hello, I am Vinita Navalkar and I am going to talk about comets, which are kind of guests in our solar system, but they have been quite frequent. Okay, so various comets keep visiting the inner solar system almost every month, and they are very interesting. Okay, comets are one of the most interesting objects in our solar system. Apart from being beautiful to look at, they also carry a lot of information about our early solar system. Okay, so here you can see one of the most beautiful image I feel, which actually shows a lot of interesting phenomena. One, you have a comet here, you also have bioluminescence happening in the sea here, and you also have a band of our Milky Way, the Sagittarius band of our Milky Way. So one of the very interesting images taken. So yeah, many a times you have some bright comets which are actually very bright to naked eyes. Many comets visit our inner solar system almost every month, and almost every day we have one or the other comets in the sky, but of course not all of them are bright enough to be seen with naked eyes. So in this particular image you can see that this comet has been fairly bright enough. In contrast to, we have a patch of Milky Way here. So in contrast to the Milky Way, we can definitely say that this particular comet must have been a good naked eye visible comet. And also, as I said, we have the bioluminescence happening in the sea. So it's in general a very beautiful composition, a shot by one of the photographers, David McCallum. Comets have been interesting objects throughout the history. People have been interviewed about comets, but we have very extensive data about comets from history, and that is recorded by the Chinese astronomers. So they have very extensive, accurate and consistent data over 3 millennium. Okay, so they have been recording comets as and when they have seen. Of course, most of them must have been the naked eye comets, and it's because of this data we have been able to track a lot of comets which are periodic in nature. Okay, so when I say comets are periodic in nature, so comets generally from the edge of the solar system come towards the sun, orbit around the sun. Most of the comets, or rather all the comets, are actually orbiting around the sun. Some comets are periodic, some comets repeats after a few years. Some comets are one-timers, in the sense they have orbits in such a way that they come close to the sun once, we see them from the earth, and then they finally, and we haven't recorded them coming back. Okay, so those are one-timer comets. So we have extensive records about comets from Chinese astronomers. So they have been meticulously recording all the comets that they have seen for over 3 millennia, and thanks to them actually we are able to find which comets have been periodic. Okay, so many of the comets repeat themselves, in the sense they come closer to sun every few years and go back. Okay, and the time period can vary between few years, 3 to 4 years, to almost few thousands of years. So thanks to these records we are able to deduce which comets have been repeatable, even if their repetition period or their period is very long, okay, in few hundred years. In fact, one of the most interesting comets and the most famous comets, that's known as Halley's comet, has also been recorded by the Chinese astronomers, because according to the records it dates back, so the first observation of Halley's comet dates back to 240 BC. Okay, so it's one of the most famous comet as predicted by Halley's, and which repeats itself after every 76 years. Okay, its orbital period is 76 years. Around in 15th-16th century, when people started observing sky in more detail and started formulating the paths of various objects in the sky, that was the time around 1577 AD when Tycho Brahe, very excellent sky observer who had collected data of almost orbits of all planets in detail, tried to estimate the distance to great comet of 1577 AD using parallax method. Okay, that is one of the methods used to measure astronomical distances. Okay, and by observation he proposed that this comet returns to their respective position in the sky following an elliptical path around the sun. So he proposed that this particular comet repeats, or rather comes back to its position following an elliptical path around the sun. Okay, so this was maybe the first time it was stated that comets have elliptical orbits. So if all those comets which have elliptical orbit return back their orbit and we see them again and again, those such comets are called the periodic comets. Okay. However, in 1681, George Dorfel also proved that the comet which appeared in 1680 had a parabolic path. Okay, what it means is it is orbiting around the sun in a parabola with sun at one of its foci, and it comes close to sun one time and we don't see that comet again. Okay. It was in fact for the same observation of the same comet, Newton also tried to formulate a method to fit the path of that comet into a parabola, and of course he was successful to do that. So this is one of the diagrams that Newton gave to fit the comet into a parabolic path. Okay. Halley tried to use the same method which Newton had stated and tried to observe almost 23 comets and tried to fit their orbit. Okay, and what he observed was pretty interesting. He observed that the comet of 1531, 1607 and 1682 had similar orbits. Okay, what it meant is it's the same comet that is repeating again and again. Okay, so based on that he predicted that this particular comet will reappear in 1758. Unfortunately, Halley was not alive to see that particular comet, but his predictions were true, and eventually this is the comet that was named after Halley, and that's the famous Halley's comet which repeats after every 76 years. Okay, so as you can see here, it's relatively pretty bright and a naked eye object. Okay, now we'll be seeing it next in 2062 again. So when we talk about orbit of comets, the orbits are very random. As we know, our planets, all the planets in our solar system orbit along a same plane, that is the ecliptic plane, more or less within plus or minus 8 degrees to the plane. However, if you study the paths of the comets, we see the orbital tilt of these comet orbits are very random. There are orbits which are at various angles. So there will be some elliptical orbits, there will be parabolic orbits, at different angles. They are not really in the plane of our solar system. They are at different angles. Itself you can see that there are some short period comets which almost within the orbit of the Jupiter. There are some long term orbits, elliptical orbits, which go quite farther away, almost up to Neptunian orbit, or you can say they originate from the Kuiper belt orbits, or there are some orbits which actually go much farther away, and those are the parabolic orbits. So generally comets are classified into two types. Their origin is classified into two types, one originating at Kuiper belt and one originating at Oort's clouds. I will be coming to that shortly. But before we go from where the comets originate, let me quickly tell you about how the comets are named. Okay, so we know that some of the comets are one-timers, some of the comets are periodic. So the periodic comets are given an alphabet P, followed by the year in which they have been observed, generally for the first time, and also in which month they have been observed. Okay, so generally we have, starting from January, so first half of January is named as A, second half, that is 15 to 30th Jan, is named as B, and so on. So first half of February is C and second half of February is D. So serially that's how we name it. So when we say P 1682 Q1, which means that it's periodic, it is first observed in 1682. Q means it is in the first half in which they have been found. Okay, so this particular comet has been found in the second half of August in 1682. Okay, similarly if you see the one-timer comet, it is called C. It is named, the alphabet given to a one-timer or a comet having parabolic orbit is C. Now this was observed for the first time in 1680, and V1 states that it becomes the first comet discovered in the first half of November 1680. Okay, so this 1, 2, 3, 4 that comes after Q1, V1 are the number of comets that are discovered in that particular month, that half of that particular month. So if there are more than one comets discovered in say first half of August, then it would be named as Q1, Q2, Q3, Q4 and so on. So that's how the nomenclature goes for both periodic and one-time comets. I was telling you about where these comets come from. So there are two regions where these comets seem to originate. The short period ones generally originate from the Kuiper belt, which is beyond the Neptunian orbit, okay, generally between 30 to 50 AU. Okay, so astronomical unit is the average distance between Earth and Sun. So 30 to 50 times of that is where this particular periodic comets originate, and these comets have elliptical orbit. The parabolic orbit comets, or the one-timers, generally come from the Oort's cloud, which is considered to be almost a boundary of our solar system. It extends from the almost from 2000 AU to 2 lakh AU. Okay, it goes almost midway up to the interstellar distances to the nearest star. Okay, so this is Oort's clouds, where we have kind of a area filled with all rocky bodies which eventually enter our inner solar system due to some perturbation that is created in the outer solar system, that may be due to some nearby stars passing by, or some other types of shock waves which actually push these rocky bodies from the Oort cloud towards the solar system, which eventually takes a parabolic path, comes closer to the sun, and then goes back to the Oort's cloud. These are the two places where comets are considered to be originating from. Now let us understand what exactly these comets are. Okay, of course they are rocks. If you see comets at their origin, Kuiper belt or Oort's clouds, they are just rocks, just as we see asteroids in our solar system between Mars and Jupiter, or even the other asteroid belt, which is of course the Kuiper belt, where we have Pluto and all other dwarf planets situated. Okay, so comets actually are just rocky particles. The minute they come closer to the sun, they start melting. These rocky particles have ice, dust, and lot of ammonia and lot of materials embedded onto it. The minute they come closer to the sun, its surface starts, the volatile material starts evaporating, and we see these kind of tails to the comets. Okay, but whenever the comet is at its origin position, it does not have a tail. Only when it comes closer to the sun, between 5 AU, that is after Jupiter's orbit, that's where rocky bodies start developing a tail, and we call them comets. Okay. So these are generally, if you see the size of the nucleus or size of the actual rocks that are orbiting, then these are just 4.7 miles, 5.4 miles, 3.4 miles. They are actually very small. These are one of few famous comets that have been observed. Okay, so this is the Temple one, which has been observed and studied by this deep impact probe. Then Borrelly and Wild 2 has been studied by Stardust mission, and this has been studied by Deep Space One mission. Okay, so these are the actual images of the comets when they are farther away from the sun. Okay, so as I was saying, whenever a comet comes closer to the sun, it whatever ice or whatever particles are there on its surface starts melting, and it develops a tail. Now this particular tail is ionized by the solar winds, and we have an ion tail directly opposite to the direction of the sun. Okay, so in fact studying the ion tail, we can actually predict where the position of the sun is and where the position of the comet is. Okay, so we have an one of the tails being developed whenever it starts coming closer to the sun. We also have another tail to comet, and that is the dust tails, which starts developing when it is actually very, very close to the sun. So generally most of the comets have two tails. This is how the two tails are. So dust tail is generally slightly, since it is moving in an elliptical orbit or parabolic orbit, and it's heavier in nature, I mean it has got dust particles, so it is generally not in a straight line opposite to the direction of the sun. It is slightly lagging due to its motion, comet's motion in the orbit. But as I said, the ion tail directly is opposite to the sun, and we can actually find out in which direction it is moving by studying the direction of the ion tail. Okay, so if you see this image, then generally these are different parts of the comet. We have the nucleus, which is, as I showed you, the rocky bodies which are very small in size. Actually if you see the size, then they are generally less than 16 kilometers. Okay, they are made of ice, dust, frozen traces of carbon dioxide, ammonia, carbon monoxide, and methane. And enveloping the nucleus, we have a cloud of dust, which generally consists water vapor, ammonia, and carbon dioxide. It is in fact the sublimated material from the nucleus itself. As it comes closer to the sun, as I said, the material on the surface starts evaporating. So all this sublimated material is collected around the nucleus, which eventually forms the tails. So that is coma. As the comet comes closer to the sun, UV rays from the sun also interact with the comet, and around the coma we have a huge hydrogen envelope being created. okay, which is generally not seen by the naked eyes at all, and this particular hydrogen envelopes extends to almost 10 raised to 7 kilometers. It is a huge hydrogen envelope around the comet. And then of course we have the two tails. One is the ion tail, which has got charged particles and also molecules of CO2 and nitrogen and water vapor and so on. And we have the dust tails, where we have a grain size of 1 microns roughly particles, which, as I said, lag behind as it moves in the orbit. So these are general basic parts of the comet, and many of the comets in fact show these two tails very clearly. So this is the elliptical orbit of a comet. So as you can see, as it is farther away from the sun, we don't have the comet doesn't have a tail, it is just a rocky body. As it comes closer, then first the ion tail is developed, and slowly the dust tail also starts growing. So as it comes further and further closer to the sun, then the dust tails become bigger. Of course the ion tail also becomes bigger. This is when it is at the perihelion position in its orbit, and we have the largest dust tail and ion tail. Eventually when it passes away from the sun, it goes back to its origin, the tail starts diminishing, and eventually it becomes a rocky particle. Okay, so this is how the two tails of comet look, and as I was saying, many of the photographs actually show two tails very clearly. So this blue tail is actually the ion tail, and this is the dust tail of the comet. This is comet Hale-Bopp. It was discovered by Hale and Bopp, two people together, and that's why it is called Hale-Bopp in 1995. It's a long period comet. Appearance roughly 370 AU. Perihelion is very close to the sun, less than Earth, almost 0.9 or close to Earth. Its eccentricity is also very high, highly elliptical orbit, and next perihelion position, that is, it is going to come, last perihelion position was 1997, and next it is going to be seen in 4385 AD. So it is a very long period comet. It's not going to repeat for another 4,000 years. Okay. So if you see the comet, as I was telling you initially, that the orbit of the comets are inclined at various angles. So if this is considered to be the plane of the solar system, most of the planets orbit in this particular plane, but this comet is actually going in this direction. So it is nearly perpendicular to our solar system plane. So this was mapped during its closest approach, last perihelion position of 1997. Okay, and it was tracked for nearly 2 years to 3 years after that as well. We have another interesting comet, that is comet Neowise, very close to Earth, visited Sun in 2020, and here again we can clearly see the bluish tail is the ion tail, and this is the dust tail. Here you can actually see the curvature of the dust tail, as I was saying, that the dust tail actually lags behind, and ion tail is exactly straight opposite to direction of the sun, and here itself you can make out that sun was somewhere down here in this direction. Okay, so this was discovered by Neowise mission, and still don't know whether, so this is the first time this particular comet has been observed. So we don't know whether this comet is going to repeat. So as of now it is considered, the number given is considered to be C. That means it is a one-time comet. So it has nearly, eccentricity is very high, close to 1, so almost near parabolic path. So next perihelion position when it is going to be, we don't know, because eccentricity is extremely high and we don't know when it is going to come next. Okay. Its inclination to ecliptic orbit is almost 128 degrees, and this is how it looks. So if this is the plane of the Earth's orbit, so this tells you that it came below the plane of the Earth and it has gone above the plane of the Earth. So this pink position, as you can see it growing, so is the path where this was below the plane of the Earth and then plane of the Earth's orbit, and now it has crossed the plane of the Earth's orbit and going above. So this is the path that it will take. This is the Martian orbit, Jupiter, and so on. Now the interesting question is, fine, we have been observing comets for so many years now. What is the importance of comets? Okay. Initially, of course, the ancient astronomers or ancient sky observers found it interesting because it's not a regular object. Okay, we see planets almost every day, we see other stars almost every day, but as I said, comets are considered to be guests in our solar system. They come, they go back, and few of them repeat, few of them don't. Okay, so people have been quite interested in knowing what these comets are. But in the modern day science, comets have been, studying comets is really important because they carry information about our early solar system, okay. They stay on the outskirts of our solar system, so they actually carry information about our early solar system, that how the condition was when solar system was formed, what type of minerals were present, what type of other elements were present. So all this information comets carry, and they are one of the oldest bodies in our solar system. Okay, so it's quite possible they must have preserved some material from the formation of a solar system, and it's necessary to study. Certain organic material that may also tell us about the origin of our solar system and also the life on Earth. So there are various hypotheses that goes that it is quite possible that water on the Earth also must be due to some comet striking the Earth in early days. There are other hypotheses which also says that life on the Earth also might be due to some comets which must have carried the organic materials on Earth. Okay, so nothing has been proved yet, but these are various hypotheses that has been stated. So studying comets can maybe shed some light you of these hypotheses. Okay. So studying comets from the Earth, we have been studying a lot of comets, tracking the paths, everything is fine. But of course, NASA has undertaken few other missions to comets, and not only NASA, in fact ESA has also undertaken one of the very interesting mission to comets, Rosetta. So the first mission that NASA undertook was in 2005, which was a deep impact where an impactor was dropped on one of the comets, Tempel-Tuttle 1. So this is this particular, you can see that the impactor was dropped, and this debris that was ejected was studied by the flyby spacecraft which was going close to this particular comet. So flyby mission means it passes close to this particular object, and at that instant only this particular impactor was dropped there. So whatever debris was ejected was studied by the mission, which gave us information about what this comet contains. Okay, this particular image is taken by the impactor itself when it was falling onto the comet. So we got some series of close-up images of that particular comet. This was the first man-made object to drop on any comet. Okay, and the debris ejection continued for almost 13 days. So this is impact position that we see almost after 13 days of impact. So for a lot of time the outgassing continued, and we could study this particular comet quite in detail. Another mission, as I was saying, was Rosetta, which was in fact an orbiter to one particular comet called 67, named as 67P. And this particular mission was pretty interesting. It also carried a lander, Philae, which landed on this particular comet. So this is the image, close-up image of that particular comet. So this in fact Rosetta mission was the final step of Rosetta mission was to actually orbit this comet and land a Philae lander. But before that it worked for almost 12 years and observed various asteroids in our between Mars and Jupiter. So as I said, roughly in 2016 it tried to 2015 and it tried to land on this particular comet. But unfortunately this particular when it landed, the Philae lander actually landed in a crater. So we could not really sustain that lander for a very long time because that crater had limited sunlight, and after some point of time the solar panels, the batteries on the Philae lander were dead, and it could not transmit the data back to Rosetta. Okay, so though we got some interesting images out of it, but that mission was not totally completed. We could not get much data from particular comet. So these are one of the few images when a Philae lander was trying to land. And you can see this is the crater. Rather than landing on the flat surface, it ended up in a crater, and some of these regions, as you see, are permanently dark or permanently shadowed. Okay, so eventually after a few hours the batteries could not work. Now this landing happened when the comet was approaching the sun. Okay, so eventually 1 year later, when it tried to when it reached its perihelion position and tried to go back away from the sun, there was a particular instance where sunlight would reach this crater, and Rosetta tried to revive this Philae lander. It did get revived, the batteries were charged, but again it sustained only for a couple of hours, and eventually this mission was declared to be over. But nevertheless, we did get some very close images of this particular comet, which you can see is totally rocky, dusty surface. So what happens to these comets? We know that every time a comet is going to visit our solar system, it's going to shred off its material, all the volatiles will be eventually gone. So in fact that is what precisely happens, that after a couple of or multiple orbits around the sun, eventually it loses all its volatile and then settles again wherever it has started from, either Kuiper belt or Oort's cloud, it settles there just as another rocky mass. Some of the comets have a different fate, like we have seen one of the biggest explosions or impacts due to a comet, and that was a comet Shoemaker-Levy that went and impacted on Jupiter. So whenever a comet tries to come to the inner solar system, many a times Jupiter becomes an hindrance, okay. Due to its large gravity, many of the comets, if they pass very close to the Jupiter, they are broken into pieces and they go on bang on the Jupiter, okay. So this particular comet was relatively larger. It was broken into pieces by Jupiter as it came very close to the Jupiter, and all these different fragments eventually went and banged on the Jupiter. We know that the orbital rotation, we know that the rotation of Jupiter is very fast, roughly 10 hours. So what actually happened is, we got a series of spots. So one fragment went and banged on Jupiter. At one point, Jupiter rotated further. The second fragment banged on another point, and after 7 or 8 different fragments banged, we got a series of these spots on the surface of the Jupiter. This happened roughly in 1994, and this was photographed by 2 missions. In fact, a Galileo mission which was orbiting Jupiter at that time, this actually happened on the other side, far side. We could not directly see the banging these fragments going and striking Jupiter live, but we only saw the spots later from Hubble Space Telescope and also the Galileo mission which was orbiting Jupiter at that point. So these are the different images taken of those fragments of comets. So this is one way most of the comets are destroyed. Another way is if the comet also goes very close to the sun, then it also, sun also breaks it into pieces. Recently, like few years ago, we had a big comet which was supposed to be a naked eye comet, that is Comet Ison, and it was expected that it will be seen naked eye, but as it went close to the sun, it was broken into the pieces, and eventually most of these pieces went and banged onto the sun itself. Okay, so most of the comets end by breaking into the pieces close to Jupiter or either to the sun, and or other comets might eventually over a period of time lose out all volatiles and stay as rocky particles in outer solar system.